Hey guys, this is Mrs. Keith, and I'm going to explain the binomial theorem today. So when you have a binomial, remember binomial is just a polynomial that has two terms. So like in this case, we have x plus a to the first power. That's a binomial because it has two terms that's been raised to the first power. You have x plus a squared, you have x plus a to the third power, etc. So we know how to multiply that out. When you do x plus a squared, that's like saying x plus a times x plus a. And we end up, you want to make sure you distribute that x through here, so you get x squared plus ax, and then multiply it through here, so plus ax plus a squared, which ends up simplifying to be what we have right here. So that's not so terrible, but when you get something like to the third power, you have x plus a times x plus a times x plus a, it becomes a little more tedious. You end up with x squared plus 2xa plus a squared. And then you still have to multiply that by x plus a, which ends up simplifying to be this right here. And then when you get x plus a to the fourth power, it becomes even more tedious. So this lesson is going to help you quickly be able to expand one of these x plus a to the nth power without having to do a whole lot of work. So what I want you to notice up here, and I'm going to erase all of that, is that when you look up here, when you have something like x plus a to the nth power, each expression, there are going to be, like here we had it to the first power. Well, we had two terms in that one. When we raised it to the second power, we ended up with 3 terms. When we raised it to the third power, we had 4 terms. So in each expansion, there are n plus 1 number of terms. In each expansion, the x and y have symmetric roles. Actually, this isn't a y, this is an a. Sorry about that. So they have symmetric roles. So I'm looking back up here again. So you've got the powers of x. So you start off here with this is x squared, this is x to the first power, and then technically this is x with no power at all, because x to the 0 is just 1. So hopefully you've noticed that these powers of x are going down. The powers of x are decreasing by 1. You can see that on the next one. It goes x to the third, x squared, this is x to the first, and then this is no x at all. All right, whereas the powers of the second term, the a value, it's going to go up by 1. So here you've got a to the first. Here you have, technically there's a to the 0 right here, and then a to the first, and then a squared. Here we have a to the 0, then a to the first, and then a squared, a cubed. So those are increasing by 1 each time. Also, something to notice is that the sum of the powers of each term is going to equal that n value. So like right here, that's a to the first right there, but that 2 plus 1, they add up to be 3. You've already got x to the third here. This is 1 plus 2, which gives me 3. Here we've got x cubed and a to the first. Those add up to be 4, like this is 4. The 2 and the 2 add up to be 4. The 3 and the 1 add up to be 4. So the number of powers, the sum of the powers of each term is going to be n. Also, what I want you to notice is that the coefficients, the numbers in front, so this has a 1, so that number, that number, that number, and then this one right here. Or if you notice here, you go 1, 4, 6, 4, and then 1. So the coefficients increase, and then they decrease in a symmetric pattern. All right, let's move forward. Okay, so on this next little part where the binomial theorem, it's saying if you want to expand something like this, you can always use this right here to figure out what your coefficients are. Like this coefficient is 1, that one's 5, 10, 10, 5, and 1. So you can use this, it's called a combination in geometry. When we did probability, we either had permutations or combinations. This is a combination where, let's take this one right here. We've got 10x squared a to the third power. So the way this works is it does n factorial. The n comes from whatever that power that binomial has been raised to. In this case up here, we've got it raised to the 5th power. So we would be writing this as c, the n would be 5 right here. The r value comes from the degree of the second term. So, here we have our second term is that a, and that a in this particular term is raised to the 3rd power. So we would put 3 right here. Now the way this works is you would do 5 factorial over 5 minus 3 factorial, and then times r factorial, which is that 3. So that ends up being 5 times 4 times 3 times 2 times 1, because that's what a factorial does. And then this is like saying 2 factorial, so that'll be 2 times 1. And then that times 3 factorial, which is 3 times 2 times 1. So if you were to simplify this, all of these will cancel with all of these. This 2 will go into 4 2 times. So that's going to simplify to be 10. Well, that 10 matches that number right there. So that's the coefficient of that term. So another thing to notice is that this x, x was our first term right here. The degrees of the x's just go down. It goes 5, 4, 3, 2. This is understood to be a 1 right here, and then no x at all. Whereas the degree of your y's, the a's right there, when you first start off with no a at all, then this is a to the 1st, a to the 2nd, a to the 3rd, a to the 4th, and a to the 5th. So you're able to figure out which terms you have used, what the terms are as far as the degrees for each of the x's and the a's, as well as the coefficient by using this pattern. All right, so obviously we're going to let you use the calculator for this section, but in your calculator, the steps in order to do this without having to actually work this out would be to type in the button 5 first to get that first number right there. And then if you hit math and then cursor over to probability and then choose option number 3, it'll bring up this. That's what you're choosing when you choose option 3. And then you're going to type in the number 3. And when you type that in and you press enter, it's going to tell you that the answer is 10. So if we do that for this one right here, we're going to type 8, and then we're going to hit math, go over to probability, and choose option number 3, and then you're going to type in 2. So let me do that real quick. Sorry, I accidentally erased that. So when you type this in your calculator, you're going to get 28. And the way that, again, that works out is you would end up doing 8, your calculator's doing this work for you. You get 8 factorial over 8 minus 2 factorial times 2 factorial. So that ends up being 8 times 7 times 6, 5, 4, 3, 2, 1 over 6 factorial, which is 6, 5, 4, 3, 2, 1, and then times 2 factorial, so 2 times 1. So all of these cancel with all of these, and then that 2 goes into 8 4 times, and that's how we ended up with that 28. So sometimes they might write it like this, and all that means is you're saying C with the 10 on the left and the 3 on the right, and then you can type that in. Let's see. I'm going to get 120 when I type that in. When you do this one, you're doing C here, 8 here, and 8 here, and that one's going to give you 1 when you type it in. All right, let's see how we can use this. Okay, so if you were going to expand these using that method, you've got a degree of 3 right here, which means that you're going to have 4 terms. So your first term will have a coefficient. The x will be to the highest power you can have it. The -1 will be to the lowest power. And then plus, you're going to have a coefficient. X will be squared. The -1 will be to the 1. So you've gone down in your x's and up in that -1 for the powers. And then here you'll have a coefficient. X will now be to the first power. The -1 will be squared. And then plus, you'll have a coefficient. X is now to the 0 power, and your -1 is now cubed. All right, now we just need to figure out what those coefficients are. So we can use this for it. We've got that 3 right there will be the number that you have on the left. you look for this number right here, and that's your R value whenever you're doing the C and R thing. So 0 will go right here. So if I type that in, here I'm just going to get 1. So this number right here would be 1 from that. For this next one, we're going to do C. The number on the left is 3. The number on the right comes from this number right here, which is 1. And so that's going to be 3, I'm pretty sure, yeah. So this will be 3 right here. And then you're going to type in C with a 3 here and a 2 here. And you get 3 again. And then you'll end up, you'll do on this last one where you'll have C and then 3 and 3. And so this will be a 1 here. And then you can simplify that. When you simplify it, you have to make sure that, like, you go ahead and raise that -1 to the first power, raise the -1 to the second power, raise the -1 to the third power. So this ends up becoming 1x cubed, or just x cubed, because that's just the number 1. And then you've got, sorry, I was about to write a plus. Then you've got minus, because you've got that -1 right there. And basically what I want you to think about is that this is all one term, this is all one term, this is all one term, and this is all one term. And you need to simplify those terms. So when you do this 3 times that -1, you're going to get a -3 and then x squared. Over here, you're going to, you have this -1 squared, which is a +1, times this 3, which gives you a +3x. And then on the last term, you've got that -1 cubed, which is just going to be -1. So this is fully expanded here. I mean, we could have multiplied it out, and that might have been a little bit faster, but when we get something with a higher degree, it'll make a better difference. All right, I'm going to erase that, and let's do the next one. All right, so on this one, you're going to have a coefficient, and then that 2x is going to be raised to the 4th power. -3 will be raised to the 0 power. I'm going to do it vertically this time just to kind of make my life easier. So then we'll do a coefficient, and then you'll do 2x, and now that's to the 3rd power. The -3 is to the 1st power. And then you'll have 2x where it's squared, and -3 is also squared. Another thing to remember is that these exponents, they will always add up to be the same as that number right there. Okay, then you're going to have a coefficient, and then the 2x is now to the 1st power. The -3 is cubed. And then the last one will be the 2x is to the 0 power, and the -3 is now to the 4th power. So we just need to figure out the coefficients. So to get this one, we're going to do C. Again, we're doing C with N here and R here. Our N number on the left will always be 4. The R number comes from whatever power that is right there. So we'll start off with 0 here. Then for this one, we'll do C41. Here we'll do C42. Here we'll do C43. And then you'll have C44. So typing those in your calculator. Okay, so these were the coefficients I ended up when I typed those in my calculator. Now you just need to simplify each of those terms. So this simplifies, you've got to raise all of this right here to the 4th power. So you're going to be saying 1, and then 2 to the 4th power is 16, x to the 4th power is x to the 4th, and then the -3 was to the 0 power. I accidentally erased that, sorry. -3 to the 0 power is just 1. So that simplifies to be 16x to the 4th. So that will be your first term whenever you expand this out. This one will become, you've got the 4, then you've got the whole 2x getting raised to the 3rd power. So that'll be 8x cubed, and then the -3 to the 1st power. And then you're multiplying 4 times 8 times -3, which is going to give you -96, and then x to the 3rd. So we'll have -96 x to the 3rd. I do want to point out, anytime you've got a minus right there in your binomial, your signs should be changing on every other one. So this next one should be positive. When you multiply this one out, you get 6, and then the 2x is being squared, so that'll be 4x squared. And then negative 3 will be squared, so that'll be 9. So that gives you 216. So then this will be plus 216, and then the x is squared. On this one, we have 4, and we're multiplying that by 2x, and then the negative 3 is cubed, so that'll be negative 27. So that gives me a negative 216x. And then the last one, we're doing 1 times positive 81. So this will be 81 right here. And this is fully expanded. In case you can't hear it, my dog is snoring next to me. Sorry about that. All right, so that's just an easier way, rather than having to do 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. Rather than multiplying that all the way out, this was an easier way to take care of it. Okay, let me move up. Okay, on this next one, they just want you to find the 6th term of this one right here. So remember, like if you were to expand this, you would have, I'm going to write it up here, you would have some coefficient, a will be to the 8th power, 2b will be to the 0, plus some coefficient, a will be to the 7th power, 2b will be to the 1st, plus some coefficient, a will be to the 6th power, 2b will be squared. Let me just write this out. That's to the 3rd power, plus some coefficient, a is to the 4th power, 2b is to the 4th power, plus some coefficient, my dog is really snoring, sorry. And then plus some coefficient, a is now squared, 2b is to the 6th, plus a to the 1st, 2b to the 7th, and then lastly we have a to the 0, 2b is to the 8th power. So it wants the 6th term. So we've got this one's the 1st, 2nd, 3rd, 4th, 5th, and then this will be the 6th term. So you're going to have some coefficient with a cubed and 2b to the 5th power. So we just got to figure out our coefficient. So right now we know that we can do c, this number on the left will be 8, and that comes again from that. And then the number on the right will be the 5 that the 2b is raised to. So when I type that in, I get 56. So that means that this coefficient right here will be 56. Now I still need to simplify this out. So we've got 56, a to the 3rd. I still have to multiply or raise 2b to the 5th power, which will be 32b to the 5th power. And then I still need to multiply the 56 and the 32 together. And when I do that, I get 1,792, a to the 3rd, b to the 5th power. So that would be the 6th term whenever I expend this a plus 2b to the 8th power out. All right, let's do another one. So now we're going to find the coefficient. Let me erase all of this. So now we're going to, Now we're going to do, this one right here, b. So it wants us to find the coefficient where a is to the 6th power, b is to the 5th power. So remember, you'll do 2x to the 11th and the negative 5b to the 0. And then it'll, that's with some coefficient up front. And then it'll be, I'm just going to write the x's and the b's. It'll be x to the, actually, let me go back, sorry. I'll do it right. So then we'll be doing 2x to the 10th power and negative 5b to the 1st power. And then you're going to do, let me write this out. Okay, I've kind of expanded this out to the 2x to the 7th power and negative 5b to the 4th. And then the next one would be 2x to the 6th power and negative 5b to the 5th power. And then it continues. But I'm going to stop there because we're looking for this one where a is to the 6th power and b to the 5th power. So that will come from this one right here. So we're going to do our c. We're going to have 11 on the left, and the number on the right will be 5. So when I type that in, I get 462. So that's the coefficient in front of 2x to the 6th power and negative 5 to the 5th power. Or, I'm sorry, negative 5b to the 5th power. Okay, so now we need to go ahead and raise that to the exponent and this to the exponent. So that'll be 462. 2 to the 6th power is 64. Negative 5 to the 5th power is a negative 3,125. And we really don't care about the x and the b because it's just wanting the coefficient, so just the number in front. So now multiply 462 times 64 times 3,125, or negative of that. We get negative 92,400,000. And that would be the coefficient. Now, if you were to get the whole term, it would have an x to the 6th and a b to the 5th at the end of it. But that is the coefficient for that. Okay, so we've just been talking about how you can use this to find the coefficients for each term. Well, another way to do it is Pascal's triangle, which might be a little bit easier. It's not like you're having to type 1,000 things into your calculator. So the way Pascal's triangle works is it's going to start with 1 on top, and all of your numbers will be 1 on the ends. This is going to look like the shape of a triangle when we're through. So then we're going to put 1 here and 1 here. Now how we continue is we take those two, we add them together to be 2, and then it has 1s on either end of it. And then those, we'll add those together. That gives me 3 and 3, and then you'll have 1s on either end. So you have 1 here. Those add up to be 4. Those add up to be 6. Those add up to be 4, and then 1 has to be on the end. And then we've got 1. Those add up to be 5. Those add up to be 10. Those add up to be 10, and then 5, and then 1 on the end. And then there'll be 1, 6, 15, 20, 15, 6, and 1. 1, 7, 21, 35, 35, 21, 7, and 1. And then 1, 8, 28, 56, 70, 56, and then 28, 8, and 1. And then it continues on forever. So when it asks you to find the 7th row of Pascal's triangle, then we're looking at, this is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th row is this one right here. So the 7th row is whenever you have like a binomial like x plus a to the 6th power. So when this power is 6, you're looking for where the second number is 6 right there. All right, let's do an example on the next page. Okay, so the way this is going to work, and we're going to go out on Pascal's triangle until we see a 5 as in the second number. So I'm just going to kind of write this out. So we're going to stop right here because our second number is 5, and that matches this number here. All right, so when we expand this out, we're going to have these numbers, by the way, that we have right here. Those will be all of the coefficients that we need. So we'll start off with 1, because this number here starts with 1. And then you're going to take that x and you're going to raise it to the highest power, so x to the 5th. And then that negative 2y will be raised to the lowest power, which is 0. And then you're going to do plus. Now we'll go to the second term, so 5. X is now going to decrease by 1, and the negative 2y will increase by 1. And then we'll go to the third term. So we start off with 10. X is now to the third power. Negative 2y is to the second power. And then plus another 10. X is now squared. Negative 2y is now cubed. And then plus 5. X is now to the first power. Negative 2y is to the fourth power, and then we end up with 1. Let me move that over a little bit. Then we end up with 1. X is now to the 0 power, and negative 2 y is to the 5th power. Okay, then we just need to simplify it. So again, we have we should have 6 terms. And I know that because there'll be one more than that right there. So there's our first term, and then second term, third term, fourth term, fifth term, and sixth term. And you need to simplify those for you to have this answer simplified. So this right here, that's the same thing as the number 1. So you're doing 1 times x to the 5th. So that first term is x to the 5th. And then actually, one thing that I should notice is that this middle sign right there is minus, which means my signs should be alternating. So this is going to be a minus now. And then that's because you've got a negative 2y raised to the first power. So when you multiply negative 2 times 5, you get a negative 10. X is to the 4th power and y is to the first power. And then we've got signs alternating, so this should be plus. And that's because this right here would become 4. Oops, that does not show up well. Let me try another color. And that's because this would be the same thing as a positive 4y squared. You need to multiply the 10 and the 4 together. So we get 40. And then the x is cubed and the y is squared. Change our sign, so that's minus. Negative 2y cubed is the same thing as a negative 8y cubed. And you multiply that negative 8 times a 10 to get a negative 80 x squared y cubed. And then over here we've got negative 2y to the 4th power, so that's the same thing as a positive 16 to the 4th power. And then you multiply that 16 times that 5, and that gives you 80 x to the first power, y to the 4th power. And then we have a negative 2y that's raised to the 5th power, which would be a negative 32. X to the 0 is just 1, and then the y is to the 5th power. And that is fully expanded. All right, that's it for our notes today, guys. Y'all have a good day. Bye.